have here is the hemp shiv, or also called the hurd, which is the internal part of the stem of the plant. And that's mixed with a lime-based binder. And so with that lime-based binder and the hemp, we've got a negative carbon footprint. Now the difference between lime and concrete is that lime you don't have to heat up as much. Concrete you have to heat up to almost 3,000 degrees, which takes a lot of energy and does very poorly on the carbon footprint.
Well, HempCrete actually sequesters carbon. Let me tell you how it does that. First of all, any cellulose material, wood for example, or hemp, takes carbon in during its life cycle, and usually when it decays, it lets it back into the atmosphere. If you take that plant and then put it into a wall, for example in HempCrete, then that carbon is now sequestered in the wall and not becoming part of climate change. So the HempCrete in this building, this one building alone, will sequester 20,000 pounds of carbon. That's a pretty big accomplishment. I think this is the best wall system in the world. So I'm all about hemp. I think hemp's an important thing to push because it's food, fiber, building material. But really, I'm choosing this material because it's the best in terms of building science. And why is that true? First of all, because this is what's often called a breathable wall system. And I don't mean breathable for air. We're actually building an airtight wall, but it's breathable for water. And why is that an advantage? Well, in a typical wall, you have a cavity that you seal tightly and then you fill with insulation. Well, water will get inside that cavity because water that's its job in the world. My body's 70% water. It can dissolve any material anyway. So what we want to do in a building is create a wall that welcomes water but doesn't rot when it lets the water in, and that's exactly what HempCrete does. When humidity changes in the air outside, the wall can take on that extra humidity and hold it until the humidity drops outside, and then it will let it back out. In the meantime, because the lime is wrapped around the cellulose won't rot.
The lime is trying to go back to being a rock. That means this wall is going to get harder and harder and harder. Over time, it's going to petrify. So these walls will last for thousands of years, not 40 years like what we're used to building.